Turning messy data into useful information. Now, the objective of this video is to help business owners understand data quality and transformation, and basically exposing them to the ETL process. Right, so starting off with the quality problem. 90% of your data is probably messy. Here's how to fix it, right? You have information, but is it good information? Most businesses don't know the answer. They assume their data is clean, but it's not. You know, the typical situation is maybe their customer names are corrupted, phone numbers missing area codes or with wrong formatting, dates in different formats, they're duplicate records for the same customer, missing critical fields, null values where you need data. So your AI receives this messy data and makes decisions based on corrupted information. And so this video is about cleaning that data before your AI uses it. So you've ever bought something online and the package arrived dirty or damaged? That's what your data is often like when it first arrives. Raw data is messy. It has typos, missing values, wrong formats, duplicates, outliers. And so your AI can't use messy data. It's like trying to build a house with bent nails and warped wood. And so this video again is about turning messy data into useful information. Now, the data quality dimensions. Let's start off with data quality. What is data quality? Data quality is the degree to which data is accurate, complete, consistent, and reliable for its intended use. Data quality has 4 dimensions, right? Dimension 1, which is accuracy. Does the data match reality? For example, your customer says they bought $1,000 worth. Right? Records show $1,000, which is accurate. For example, right? Their customer records show $10,000 wrong, which is not accurate. What happens if it's missing? The wrong decisions are based on the wrong numbers. And so how to measure? Compare records to source of truth, customer statements, receipts. How do you fix it? Through validation rules, data reconciliation, and the impact if it's broken is 10 to 40% accuracy loss in analysis. Secondly is completeness, right? So is all necessary data present? No missing pieces. For example, does the customer record have the name, email, phone number, address? Is it complete? For example, the customer record could be missing an email, which means it's incomplete, right? And so what happens if it's missing? Incomplete understanding, means you can't email the customer. And so how to measure the percentage of records with all required fields populated? And so how do you fix it? Require critical fields, data imputation. The impact if broken could be 5 to 30% of analysis, which is impossible. 3, consistency. All right, is data uniform and matching across systems? For example, your customer database shows John Smith, your CRM also shows John Smith. That's consistent. Then there's the customer base database shows John Smith, the CRM shows JS. That's inconsistent. And so what happens if it's missing? There's confusion, duplicate records, reconciliation, nightmares. So how do you measure this? Check if same entity has same values across systems. How do you fix it? Master data management, data deduplication, duplication. The impact, if broken, is 20 to 50% increased operational work. Then fourthly is timeliness. Is data fresh and current? The customer's current status updated this hour could be current. There's also a possibility that the customer's status from 3 months ago is not current. And so what happens if it's missing? Decisions are made on old information. How do you measure do you measure this? Age of most recent data update. And so how do you fix this? Increase freshness, just like I had mentioned in the previous video, and real-time sync. Impacts, if broken, is 10 to 30% decisions based on stale data. And so a better way I could explain this is using an analogy, right? Starting with number one again, right, which is accuracy. It's like, does the dish taste like what you ordered? In data, is John Smith actually John Smith? Is his address correct? Bad accuracy, for example, going back to the restaurant, is Chicago listed as Chicago, spelled differently? The impacts, the customer emails don't deliver. Secondly is completeness, like, does the dish have all ingredients? In data, does customer have a phone number, address? The bad completeness is the customer with no email you can't contact. The impact is you can't reach customers. Thirdly is consistency, right? The same across systems. Like, does the menu match what customers see? In data, is customer active in one system and inactive in another? So the bad consistency is, customer marked as duplicate in system A, and then there's active in system B. The impact of this is the confusion and duplicate communications. Fourthly is timeliness, right? Is it current? Like, for example, is the food fresh? In data, is this information from today or 2 months ago? Bad timeliness, you're using last month's pricing. The impact, recommendations based on outdated info. And so all four matter. Missing one breaks the system. This leads us to the data pipeline transformation, right? Starting off with the ETL, which is the ETL process, which is the extract, transform, load process. What is ETL? ETL is the automated process of extracting data from source systems, transforming it through cleaning, standardizing, enriching, and loading it into target systems where it's usable. Professional data cleaning follows a standardized process called ETL. So starting off with E, which is extract, right? Which is basically step one, get data from sources. Pull customer data from the CRM, pull transaction data from payment system, pull inventory from warehouse system. Extract happens periodically, daily, hourly, real time. The task at hand is essentially to physically move data from source to temporary staging area. The duration could be minutes to hours depending on volume. Then there's transform, right, which is step two, which is the where you clean and standardize the data. This is where most work happens, cleaning tasks, fix formatting, standardize all dates to the same format, standardize all phone numbers to the same format, fix capitalization, all names to title case, remove extra spaces and special characters. Secondly is handle missing data, identify null fields, decide, fill with defaults, delete record, impute value. What is common is you mark as unknown or fill with most common values. Then it takes us to transform, which is step two, where you clean and standardize your data. So this is where most of the work happens. Cleaning tasks, fix formatting, standardize all dates to the same format. Standardize all phone numbers to the same format. Fix capitalization, remove extra spaces and special characters. Second is handle missing data, identify null fields, decide, fill with default, delete record, impute value. The common practice is to mark as unknown or fill with most common value. Thirdly is remove duplicates. Find records that match on key fields. Keep one, remove others. Resolve conflicts. Use most recent data. Right. Fourthly is validate against the rules. Email must be valid formats. Age must be between 0 and 120. Purchase amount must be positive. Date must be reasonable. Fifth is enrich data. Add derived fields, age from birth date. Add lookups, state from zip code. Add categories, classify customer as high value, low value. Duration could take anywhere from hours to days depending on complexity. Then there's load, which is the third step where you move cleaned data to target. Where you load it into the data warehouse, load it into real-time store, load into knowledge base, and make available to AI systems. The duration could take anywhere from minutes to hours depending on volume. Complete the ETL cycle, right? So this is the complete ETL cycle essentially. Extract, which could be 15 minutes maybe. Transform could take hours. Load 30 minutes equals complete. Refresh takes, which could take it takes hours. This whole process takes hours. So typically run at night so it doesn't interfere with operations. So why does this matter? Without ETL, raw data goes to AI. AI gets wrong inputs. AI makes wrong decisions, cascading failure. With ETL, data cleaned first. AI gets good inputs. AI makes good decisions, and the system becomes reliable. So if I have to use an analogy with this, right? So turning messy raw data into clean, usable data is called ETL. Think of it like a mail sorting facility. Extract, you get the mail, grab all incoming data from every source, such as Salesforce, databases, APIs, CSVs, which is raw and unprocessed. Transform them, sort and clean the mail. Fix typos and inconsistencies, standardize formats. Remove duplicates, fill in missing values, validate correctness. Then you load, deliver where you deliver to the destination. Put clean data into the warehouse, make it available to AI, make it essentially just making it ready to use. So, and yeah. Now this leads us to data quality rules. And so what are data quality rules? To be specific, there are measurable criterion that data must meet to be considered of acceptable quality, with defined validation method and handling for failures. For each critical data source, you need to define quality rules. Step one, right, is you identify critical data from your inventory. So step one, identify critical data from your inventory. Which data must be accurate? For example, customer email, your payment amount, order status, inventory level, customer address. Pick 3 to 5 most critical data sources. Step 2 is define quality rules. For each critical data source, create rules. For example, your customer email field. Rule 1. Email must not be empty. If it fails, mark record as invalid, don't load to warehouse. Detection, check for null or blank, right? Rule 2, email must have valid format. If fails, marks record as invalid, don't process. Detection, check for maybe a at symbol, domain suffix, and that of the sort. Rule 3, email must be unique, no duplicates. If it fails, keep most recent, delete older duplicates. Detection, check for duplicate email values. For example, the payment amount field. The rule 1 would be the first rule would be the amount must be positive number. If it fails, mark transaction as invalid and investigate. Detection, check that the value is more than 0. Rule 2, amount must be reasonable, and if it fails, flag for manual review, check that value is correct. Rule 3, amount must match source system. If it fails, flag discrepancy for investigation and that of the source. And so essentially, I could explain this better with an analogy. Using an analogy, ETL isn't random, it follows strict rules. Think of it like quality control at a factory. Validation rules, does it pass inspection? Such as the email format must contain the @ sign. The phone must be 10 digits, price must be above 0. The date must be valid, and there's standardization rules, phrase like what I had mentioned, the format, the phone format, name format, date format, the currency, there's deduplication rules. Same email equals same person, right? The same phone plus name equals the same person. So you must keep the most recent version. There's enrichment rules, which is adding missing pieces. No state, infer from zip code. No region, infer from state. No country, assume the US if appropriate. Companies with strong data quality are Uber. Every transaction is validated. Netflix, every user profile standardized. Amazon, duplicates, detection across billions of records. Companies with weak data quality get wrong recommendations, send duplicate emails, make bad business decisions, waste time on manual fixes. And so data quality rules are essential for machine learning. 80% of machine learning failures are data issues, not algorithm issues. Quality monitoring prevents problems. And so there are real world case study, which is the data quality disaster. So what is data quality degradation? Data quality degradation is the gradual or sudden decline in data accuracy, completeness, or consistency as systems change or integrations fail. For example, a marketing cloud integration failure. Let me tell you about a company that learned this lesson the hard way, right? So this company was essentially just a mid-market SaaS business where they're experiencing a problem where they were sending email marketing campaigns. One campaign had a specific goal, which is personalized recommendations. The AI was supposed to say, John, based on your purchase history, we recommend product X. But something went wrong. Emails went out. Some customers got John Smith. We recommend product X, which was correct. Some got J Smith. We recommend product Z, which is the wrong product. Some got name not found. We recommend product X, but there's no name. Some got John Smith. We recommend product John Smith, which is that data is corrupt. Right? The campaign was a disaster. Click rate was 0.5%, which is far below the standard of 3%. Now, what happened? The data transformation pipeline failed. Here's the sequence. Number 1, Marketing Cloud pulled customer data from Salesforce. Second, the transformation rule, take first name from name field. Thirdly, but some customer records had name as Smith, John, last first. The fourth is system extracted Smith as first name, which was wrong. Fifthly was other records had name as null. Sixth is system showed name not found. Seven, some records had weird characters. Eighth is system output it was corrupt. No validation rules, no transformation errors logged, no quality checks. The cost of this was low email click rates, 85% fewer conversions, resulting in a lot of lost revenue, manual fixing, customer databases, reputational damage. All of this resulted in a huge loss in revenue. And so, how would they have prevented this? They would have prevented it through validation rules. Check, does this look like a name? Error logging, log when transformation fails, quality monitoring, and testing. The lesson is every data source needs quality rules. Every transformation needs validation. Every pipeline needs monitoring. And so, how do you implement? It takes us to how do you identify critical data for your business? Which data matters most to your AI? Your customer name, critical, which is used in personalization, phone numbers, medium used for contacts, website visits, visited low, it's more informational. This you'd rate each from 1 to 5 by importance. Step 2, you define the quality rules. For critical data, what makes data good? What validation rules exist? How to fix common problems. For example, your customer email, good, matches email formats, contains at bad, empty, or invalid formats. You fix, mark as missing, don't infer. Step 3 is implement checks. Where does data come from? Salesforce. Add validation on exports. Database, add validation on inserts. API, validate on receipts. Don't assume data is clean, check it. Check step 4, monitor quality. What percentage of records pass quality checks? 95, maybe over 95% is clean, which is good. 85 to 95% clean, needs improvements. Less than 85% clean, it's a problem, so you'd have to fix the source. Step 5 is to improve continuously. When you find bad data, fix it in the source system. Updates validation rules, log what failed, learn for next time. So what you now understand, right? Data quality has 4 dimensions: accuracy, completeness, consistency, timeliness. Professional companies use the ETL process: extract from sources, transform to clean, thirdly, load to systems. You must define quality rules for critical data. The typical ROI on data quality investments is anywhere from 5 to 20x.